Now let us see about direct memory access. In direct memory access, there is direct communication between memory and the peripheral devices. The transfer of data between a fast storage device such as magnetic disk and memory is often limited by the speed of the CPU. And removing the CPU from the path and letting the peripheral device manage the memory buses directly would improve the speed of transfer. This transfer technique is called as direct memory access. CPU bus signals for DMA transfer. In this diagram, there are two signals. One is bus request and another one is bus grant. The bus request, this line indicates the signal for requesting the bus, and BG, bus grant. On receiving the BR signal, CPU stops its work on bus and assigns bus to BMA controller. This will be indicated by enabling the bus grant line. D bus is data bus. This will be a bidirectional. A bus is address bus. BR, that is bus request. The signal is used by DMA controller to request CPU for the buses. And CPU then places the bus on the high impedance state, which behave like open circuit. CPU then activates BG, that is bus grant, the signal to acknowledge BR signal. Then DMA now has full control over the buses and perform the transfer. Transfer can be performed in two ways. One is burst transfer, another one is cycle stealing. Burst transfer, a number of memory word is transferred in a continuous burst. An entire block of data is transferred in one contiguous sequence. One of the DMA controller is granted access to the system bus by the CPU. It transfers all bytes of data in the data block. In cycle stealing, one data word is transferred at a time. In this method, system allows DMA controller to use system bus to transfer one word, after which it should return back control of bus to CPU. This method reduces maximum input-output transfer rates. This is also called as transparent DMA. DMA controller. A DMA controller can generate memory addresses and initiate memory read or write cycle. It contains several processor registers that can be write or read by the CPU. In this diagram, the DMA controller communicates with CPU through data bus and control lines. Registers in DMA are selected by CPU by enabling DS and RS. RD and WR signals are used for read and write operations. When BG equal to 0, the CPU can communicate with DMA register for read or write operation. When BG equal to 1, DMA communicate directly with the memory. Address bus buffer, it deals with the internal address. Address register, it shows the address of the data to be fetched or to write. Word count register, it tells the number of words to be transferred. Control register, it specifies the mode of the transfer. Control register specifies the mode of transfer. The DMA is first initialized by CPU. After that, DMA continues to transfer data. Then CPU initializes the DMA by sending the following information through the data bus. The informations are starting address of memory block for read or write, the word count or number of words to read or write, control to specify modes such as read or write, Control to start DMA. Once DMA is initialized, CPU stops communicating with DMA unless it receives interrupt signals or if it wants to check how many words has been transferred. IOP, Input Output Processor. IO processor communicates with DMA. It handles all input-output operation. Input-output processor can execute its own instructions without the help of CPU. Input-output processor can access memory, CPU, and all peripheral devices. Let us see about block diagram of computer with input-output processor. In this diagram, memory occupies the central position and can communicate with each processor by DMA. CPU is responsible for processing data. Input-output processor provides the path for transfer of data between various peripheral devices and memory. Data formats of peripherals differs from CPU and memory. Data are transferred from input-output processor to memory by stealing one memory cycle. The instructions are read from memory by input-output processor are called commands to distinguish from instructions that are read by CPU.